All right, chapter 7's behind us. Chapter 8, ahoy. Um, and so here we are. Yet again, what is it we're doing? We're working hard, right? We're here to work hard. We're here to imagine our dreams, and we're here to make them happen. I know it sounds maybe a little bit silly. I know. You might say, "What? doing doing dozens, if not hundreds, of homework problems in my Math 121 class is perhaps the furthest thing from my dreams." But I would argue that that's maybe not the case if we really sit down and think about it. Right? I mean, I'm a big believer that doing these homework problems is important for understanding the material. Understanding the material is important for doing well in the tests. Doing well in the test is important for getting a good grade in the class. Getting a good grade in the class is important for whatever degree it is that you're pursuing. Like it, don't like it, agree with it, don't agree with it. You're taking this class because they told you you have to do it, and you're like, all right, I'm just going to buckle down. I'm just going to buckle down and I'm going to do it, right? Whatever your dream is, unless your dream is I don't know, unless your dream is like sitting on the couch, eating ho-hos, playing Madden. I don't even know what year it is right now. Madden 2022. And unless that's your dream, it probably is going to require some discipline to get there, right? And disciplines, it's just a muscle, right? How do we build muscle? We build muscle by exerting muscle. We build physical endurance by exerting our endurance, and we build discipline by exerting our discipline. I know you don't feel like doing these homework problems. I get it. I have to admit, typing these things up, trying to draw these kind of awkward, horrible, shaky pictures of normal distributions, sitting down, in my basement slash recording studio and narrating these PowerPoints. I mean, you think that this is tedious for you? I've actually done these problems one way or another, probably without exaggeration, more than 100,000 times. But here I am, time 100,001 with you, and that, of course, is what makes it so special. Doing it yet again. I'm doing it because why? Because my dream is to be a better teacher, and being a better teacher is trying to do things, right, whether I want to do them or not, that will hopefully set my students up for success. And you're doing this because you want to be a better whatever it is that you're training for. And it's an important step for both of us. It's not an easy step, but of course that's what makes it so important. So, right, by chapter 8, we're starting to get close to the last 1/3 of the class. We're starting to get a little bit close to the end of the semester. At the same time, like burnout might be setting in, but at the same time, like the end is a little bit in sight. And so let's try to focus on that, and let's see if we can kind of dig deep. Let's see if we can find our second wind. So here we are. We're doing confidence intervals. I would encourage you should always be listening to the narrated PowerPoints before doing the practice problems. So if you've listened to the narrated PowerPoints, you already know kind of like what a confidence interval is. 8.1 is all about finding confidence intervals for the population mean when sigma, remember sigma is the population standard deviation, is known. First couple problems I think are very generic. So first problem just says a sample of size 49 is drawn from a population whose standard deviation is sigma equals 4.8. Now that bold-faced emphasis is my own because I'm going to try to condition us to like look for keywords. Anytime I see that sigma is shorthand for population standard deviation. Anytime I see that, that's telling me, okay, I got to do a z interval for the mean. Now the actual question tells us to find the margin of error for a 95% confidence interval. So the margin of error formula, right, we remember from our lecture, is z times sigma over the square root of n. Z is the critical value, It could be found in our textbook. It could also be found in the slide from my narrated PowerPoints. For 95%, it's 1.96. So that's the only one I would expect you to know on a test. Now, your Math Connect quizzes might ask you for some other percentages. To me, that's fair game because those quizzes are open book, open notes. Now, our test is closed book, closed notes. So I'm not going to expect you to memorize a whole bunch of them, but I do expect you to know, oh dear, I could feel a cough building. I apologize in advance. I'm going to try to suppress it as best I can. I do expect you to know that 95% is 1.96. So you might want to make a little note somewhere, make a little flashcard, kind of whatever, when you're driving. Not literally while you're driving, but at a red light or in a parking lot or whatever. Just kind of keep reinforcing that. I mean, it's not that hard. 95%, 1.96. You do that a couple times. It'll burn its way into your short to medium term memory. So we just take all the numbers, right? So we take that 1.96, which is based off the 95% confidence. We take the 4.8, which is provided by the problem. We take the square root of our sample size, which we're told is 49. Again, this is a little bit of like a complex calculation to put into a calculator. So don't just like look at it and say like, oh yeah, I know how to multiply and divide. Order of operation has humbled many a man and woman. So make sure, like, take your calculator out, make sure that you can verify and get that 1.344. Then 33B just says if the sample size were 60, which is larger, what would happen to our margin of error? We talk about this in the narrated PowerPoint. We say that sample size and margin of error have a negative relationship, right? Intuitively, a larger sample size is good. That is, there's more information. And so that should reflect itself how? It should reflect itself in us having a smaller margin of error, less error. And so it should be intuitive to you that they have a negative relationship. All right, so 35A, same idea. We have a sample size of 32 drawn from a population with a standard deviation. Bold-faced is sigma of 12.1, so that sigma tells me I'm using a Z interval. The first question is find the margin of error for 99% confidence. So the same places I told you in the previous slide, you could find that 99% confidence is 2.576. You may need that for a pop quiz. You're not going to have to know that for a test. I would only expect you to know the 1.96. I do expect you to kind of know the formula though, so that we take that critical value, we multiply it by the sigma, we divide by the square root of our sample size. Again, verify in your calculator that's 5.51. Big picture concept question. If we wanted less confidence, what would happen to our margin of error? If our confidence decreases, it turns out our margin of error also decreases. So they have a positive relationship. They go in the same direction. To me, I actually try to think of it intuitively in the opposite direction. So like I think about like, well, what if I wanted to be like 100% confident? Well, it turns out, right, what I always like to say is confidence comes at a cost. Right? If I want to be 100% confident that my interval really does contain the true mean, the only way that I could be 100% confident is to make that interval so large, so vast, that it has to include the true mean. Although at that point, it's potentially so large that it's a little bit useless to us. So if we think about it that way, the only way to be 100% confident is to have the interval be really, really large. The flip side of that is, okay, if I want to have a low confidence, that's going to translate to a small confidence interval or correspondingly a small margin of error. All right, I think there's just one more problem. This one's a word problem. Again, you should be ideally trying to solve these before before listening to the narrated PowerPoints. I don't want to point any fingers, but it feels a little bit like cheating if you just jump straight to me doing the narrated PowerPoints. You learn by doing, not by listening, which I know I've already accused you of cheating, and now I'm sitting here being kind of preachy. But I mean, what can I say, right? Truth is truth. So if you want to do well, if you want to learn it yourself, you got to do it yourself. So if you haven't already, pause this, do the one last problem. I want to say it's problem 43. If you look on the syllabus, it'll tell you. Try the problem, and then we'll go compare our answers in just a second. And go. Yeah, 43. So a college admissions officer takes a simple random sample of 100 entering freshmen and computes their mean mathematics score to be 458. Assume, and again, that emphasis is my own. If you've only done 8.1, it may not be apparent like why I'm making such a big deal. But by the end of chapter 8, we're going to have to learn 3 different confidence intervals. And they're easy to do. You can do all of them in your calculator. Just got to pick the right function. So there's sort of 3 functions in our calculator. Now on a test, the only real challenging part is picking the correct function, right? So you have these 3 different confidence intervals, these 3 different functions in our calculator. And for a given word problem, we have to pick the right one. At this point, we've only learned one, so it feels simple. But I'm trying to train us now for when the time comes that we have to actually be picking between all 3. And I'm trying to train us to zero in on certain key phrases. The key phrase that's relevant to us is that population standard deviation. Anytime you see that phrase, that's telling you to do a Z interval, to do the confidence interval you learned how to do in section 8.1. So it says, construct a 99% confidence interval for the mean mathematics score for the entering freshman class. So let's go ahead and do that. Now, most confidence intervals I would encourage us to do in our calculator. Again, if you've done the narrated PowerPoints, I've already shown you how to do this. You start by hitting the stats button. Of course, it's stats class. You then you can hit the right arrow key over to tests. Of course you do. This would be pretty darn useful on a test. You actually then, I think, hit the down arrow key to Z interval, although it actually might start off right on Z interval, but one way or another, select Z interval out of that test menu. Once you've selected Z interval, you got to make sure your input method is stats, which if you've done it once, it will, I think, stay there for the rest of the class. So that step you only should ever have to do once. And then you fill in a bunch of information. So there's the information, and notice there's where, if you look at the very top line, you see that input thing. See, I moved it over to stats. If yours is on data, it's going to look a little different under there. So if it's not already, move it to stats. And then you just fill in those numbers. So there's that little sigma symbol. That's the population standard deviation. We were told that that's 116. There's X bar, it's the sample mean. We were told that's 458. There's our sample size N. We were told that's 100. That's the confidence level. We were told that should be 99%. Now make sure that you put 0.99. I'm not 100% positive, but I think if you were to put 99 without the point, that you would get an error. So make sure you put the decimal place in there, because it's really 99%, right? So 99% corresponds to 0.99. And then I put my little cursor over calculate. I hit the enter button. And there's my answer. I mean, it doesn't get much easier than that, right? It's what we in math or statistics call plug and chug. The only slightly hard thing is picking the correct confidence interval, right? Picking that Z interval. Because we'll see there's 2 others that we need to learn and pick from kind of coming down the road. And that's why zeroing in on certain keywords is so important. So our 99% confidence interval is 4.28.12 to 487.88. So I would say that we are 99% confident that the true but unknown mean mathematics SAT, should say SAT score, sorry, SAT score for all entering freshmen. We don't know exactly what it is, right? I mean, if you work for the SAT company, you know, but like we from like a college perspective, when we're trying to actually like think about like, okay, like what was the average math score? That'll help us know whether any individual student score is right, good or bad. We don't know exactly what the true mean math score is, but we're quite confident. We're 99% confident that it's somewhere between that 428 and that 487. I guess we'd maybe bump that up to 488. And then part B, it says, if our sample size increased, what would happen to the margin of error? We actually already answered a question like that, right? So this is just reinforcing. When our sample size increases, that's more information, so our margin of error would decrease. So that would translate to an overall smaller confidence interval. I mean, try it yourself, right? I mean, I think it would be a good practice. It would be a good lesson for you. I mean, you should be able to answer questions like that, and I do like to put questions like this on my tests. You should be able to answer that without having to plug the numbers into the calculator, but sometimes seeing is believing. So you have a very specific number, you have that 100, plug it in and see for yourself that the confidence interval does in fact shrink. Then, right, it says, okay, what if our confidence decrease? We actually solved something like this. If the confidence decreases, margin of error decreases. We already answered this question in a different problem. But again, for this one, try plugging the 0.95 in and see for yourself that it does in fact get smaller. Now D says, okay, do you think if someone told you that the average score was 500, if they made a conjecture, they said, man, I'm telling you right now, like this particular graduating class, man, they're really on point. Like I think in terms of their math, they're so sharp that on average, this particular class got a 500. Do you think that that's a true claim or not a true claim? Does that claim agree with what we've observed in our data, or does it not agree? I would say it doesn't agree, right? We don't know what the true mean is, right? Because we don't have all the information of all the thousands upon millions of students that took the SAT. We only have access to that random sample of 100 students. But just based on that random sample of 100, we're pretty confident that the mean is somewhere between 428 and 488. But notice 500 is not in that interval. So we don't know what it is, but we do have it narrowed down to like a plausible range of values. And that plausible range of values does not include 500. So if someone comes at us and tells us, hey, I think that the mean is 500, we would say, I'm sorry, but I have to politely disagree with you. Yeah. Just because we know more statistics than this person doesn't mean we can't be polite about it. And there you go. That's 8.1 in a nutshell. So why don't you go ahead, take a break, take a breather, and then we'll come back, we'll push on, and we'll keep pursuing our dreams together. I'll see you soon for 8.2.